Okay, so remember the whole purpose of what we're doing is to try to make things easier. So if you go back to the ancient Greeks said that everything was made of atoms. Okay, so you had one particle. Okay, then later we found out that these atoms consisted of an electron and then a nucleus. So we were down to two particles. Then we found that the nucleus consisted of the neutron and the proton. So then we had three particles that could explain stuff. Then we, through the high energy collisions of particles, we found out that inside the protons and the neutrons were the quarks. And we needed to have 6 different kinds of quarks, and we needed to have 6 different kinds of leptons in order to explain matter. Okay? So things are getting worse. So again, we really want to just have one particle that could explain all of these other kinds of particles. And so they have come up with the concept of the superstring. So a superstring is going to be a vibrating piece of energy. And depending on how it vibrates, it can be any kind of particle that you need. So that if you've got, let's say you got a violin, depending on where you put your fingers on the violin, you can produce different frequencies. So one frequency, when a superstring is vibrating, could turn into a quark. But when it vibrates at a different frequency, it could be a photon. And then when it vibrates at another frequency, it could be a Higgs boson. So depending on how this one particle vibrates, it could turn into any other particle that you're interested in. So this is one way of simplifying the particles down to just one particle. Now, we haven't seen a superstring yet, so this is theory, but it's possible. So I'd like for you to watch this little video, Superstrings by Fermilab. Okay, got it? All right, now, how can we simplify the fundamental forces? So there are 4 fundamental forces. So let's put gravity down here at the bottom. Okay, and then up here at the top, I'm going to put the electromagnetic force, and then underneath that, I'm going to put the weak nuclear force, and then underneath that, I'm going to put the strong nuclear force. Now, we have a theory that says that if you increase the temperature of the universe, these two forces will go together. So these two forces combine at very high temperatures. So how hot? It needs to be 10 to the 15th Kelvin, which is equivalent to 1,000 times hotter than a supernova. So if that was to happen, these two forces would go together, and then we would have what's known as the electroweak force. So it would be a combination of these two forces. So then the universe would only consist of 3 forces: the electroweak, the strong nuclear, and then the gravitational force. And then it would turn out that there would be a carrier for the electroweak force, the same way that there's a carrier for the electromagnetic and a carrier for the weak nuclear force, and it's called the W1, W2, W3. Don't worry about it. Okay, so this has been verified with particle accelerators. We really have gotten things up so that they're so hot that these two forces have gone together. So we've got the theory, we've got the experiment that shows that this is true. But we want to go further. So then there is a theory that shows that the strong nuclear force and the electroweak force go together at even higher temperatures 10 to the 27th Kelvin, which is 1,000,000,000,000 times hotter than a supernova. And then that's going to create another force of nature called the Grand Unified Theory, or GUT. So then you would have only two forces that would control the universe. So you would have GUT and then gravity. Now we have a theory for the Grand Unified Theory. So we actually have the mathematics for it. The problem is we just can't generate a temperature high enough to verify the formula. So it hasn't been verified yet. But that's not good enough for a lot of scientists because they want a theory of everything. So what they want to do is, if these two forces go together at a high temperature, and then these two forces go together at an even higher temperature, could there be an even higher temperature at which those two would go together? And so if those two go together, that's going to be called TOE, which stands for the theory of everything. And so that would mean you would have one fundamental force that would control the universe. Now, we don't even have the theory for this one, much less being able to generate the temperatures necessary in order to verify it, because gravity is controlled by the general theory of relativity. These three are controlled by quantum mechanics, and the two of them don't mix. You can't use the general theory of relativity to explain atoms, and you can't use quantum mechanics to explain galaxies. So the two theories are just incompatible with each other. So possible ideas for what TOE is going to be is quantum gravity, which is going to be a combination of quantum mechanics and the general theory of relativity. Another possibility is that we live in 11 dimensions. So 4 dimensions explains the theory of gravity, space and time. So 3 dimensions of space, 1 dimension of time go together to make space-time. So they think that if 4 dimensions gives you gravity, then if we include more dimensions to our universe, that would include these other forces. And so they calculate that you need 11 dimensions in order to be able to do that. So here is our chart, and it shows how all of these things go together. It shows when the temperatures necessary to do it, and then at the bottom it shows you when in the universe's history did it have those temperatures. So we'll talk more about that when we talk about the origin of the universe and the Big Bang in our next lesson. Okay, let's take a break, and when we come back, we're going to talk about supersymmetry and superpartners.